said before, there's no need to have seen any of the previous sessions, as each of these is essentially a all-encompassing. And we cover just really what you need to know. The idea was that we'd be at the Queen Elizabeth Planetarium doing this, but until then we're doing Zoom. So hopefully this autumn we'll be able to do that. But the idea is simply to imagine we're around a campfire and we're sort of pointing out stars and features. And each time we'll do something different. And over the course of the year, we'll look at some of the different cycles of the motion of the moon or the sun in the sky, and how it affects what we see. And the focus is on things that you can see with your eyes. So you don't necessarily need a telescope, but binoculars can be helpful. So things like where the planets are, noctilucent clouds, which I'll be talking a bit more about later this evening, the northern lights, and things like comets. But the idea is just get out there, look up, remember to use the names of the stars that we talk about, and this way it becomes a very much more familiar kind of setting. And before you know it, you'll know the names of the brightest 20 stars. And along with this, as we touch on the various subjects, we'd like you to follow along, print out the Royal Astronomical Society of Canada's Explore the Universe program. We've got a link on the webpage, and fill it out as we go along. But of course, you have to actually go outside and look up at the sky and see the things that are in the pages. And so there's, as I said, no need to feel that you're behind. You can come in at any month, and within a year or 18 months or so, you should be able to collect enough observations, just very simple jotting down notes to get it. Here's a couple of sample pages from the Explore the Universe. So for example, you need to be able to identify 12 out of 24 constellations, some of the names of the brightest stars, and just record whether you've seen it, and a log page in the back to write notes. Things like, have you noticed the different lunar phases, and so on. Simple log book, just what it was, when did you see it, what did you use to see it with, and a little bit about what it looked like. So our host society is the Royal Astronomical Society of Canada, with about 5,000 people across the country. And most folks are just people off the street with an interest in stargazing and the universe, and taking pictures with their cameras of the sky. There's very few, very, very few who are actual university professors in astrophysics. There are a handful, but most of us are just sort of normal people with from very many different walks of life. And we'd like you to join the society, of course. There's a lot of good people met all around the world. Whenever I've had a chance to go to a different city, I try and hook up with the Astronomy Society there, because they're essentially people like us. So there's a lot of advantages to joining the RASC, a lot of help, things like this sort of session, and more higher end sessions. For the brightest space station up there at the moment is the one and only International Space Station. It orbits the Earth in about 90 minutes and moves across the sky with the speed of a high-flying plane in terms of angles, but in reality, it's going a lot faster than that, because it has to orbit the entire Earth in a matter of 90 minutes. But it looks like a really overly bright star, and just does a nice slow cruise. Right now we're in a really great time to see the International Space Station. It's doing 4 passes in one night. So that means as we hit mid-July in a couple of weeks, 3 weeks, you'll be able to see it, for example, just before 11 o'clock, midnight 30, 2 o'clock, and then just after 3 minutes 30. So you can see the 90 minutes there. It's not quite 90, it's a little bit more than that, 95. But, and then it'll do the sort of the same thing the next night and the next night. And the passes go from sort of fairly low, the highest point, up to very high in the sky after midnight, and then starts to go back down again. So it's pretty cool to be able to see that. And so you can either, of course, go to the web page for our session here, and I've listed this very image so that you can get the times. But if you want more times than just this handful of days, go to heavensabove.com. Make sure you change your location to Edmonton and click on one of these passes that looks like will be reasonable for you, and it will pop up a chart very much like this. And so the chart will have the constellations laid out. It won't have the big S like you're seeing down here for south, and it won't have the labels of the bright stars, which I added for our session. But it does tell you at what time, 2254, 2256, 2258, where the International Space Station will be against the background stars. So this, in particular, is July 13th. But from a generic point of view, if we drop the International Space Station part for the moment, this chart is for the entire sky. So the middle of the chart is straight up overhead. And if you point the bottom of it, which is south, you need to face south and then have that S at the bottom like this. And this point will be overhead, and Capella in Auriga will be behind you. And rising in the east, we have the summer triangle. Setting in the west, the bright star Spica, bluish white, and the very nicely orange Arcturus. So just try and remember, familiarize yourself with the names. Just sort of go out there with the chart, repeat the name, Spica, Arcturus. Remember the dipper, the handle of the dipper, arc to Arcturus, spike to Spica. And then the summer triangle is, we're going to see now well into October. It will be the prime feature of the evening sky for the next few months. So the blue-white one leading, Vega, Deneb, and Altair. Deneb is slightly yellower compared to the blue-white of Vega and the blue-white of Altair. So those are the key star names that will help you navigate the sky, and as well as that this is always the sky you'll see every spring due to the clockwork nature of the way the Earth moves around the sun. And so when you come around and learn the stars this spring, by the time they sort of disappear over winter, and then they'll reappear in the evening sky we're talking about here. They'll reappear in spring, and then go, oh yeah, I remember this last year. And so with that, looking deep into the south, we're going to be focusing on Sagittarius, which is this thing way down here, close to the horizon. Jeff, in his monthly What's Up in the Sky, likes to talk about how low Scorpius is, and here's Scorpius sitting down here. Very low, much more prominent when you're from Toronto or New York or LA. They're much higher in the sky, much more prominent. But from our latitude here, this part, the south part of the sky, gets lower and lower. And so it's just grazing the south down. So here's a evening view. A few more stars than you'd see from the city, but from the country, there's still a little bit of light left from the permanent twilight, as we like to call it here. The sun is only just below the horizon in crossing the north. And as our Canadian Arctic experiences 24-hour daylight, but down here we get just twilight. And Antares is the nice orangey bright star, which will be just to the right of south. And it's known in the Cree as the red star, and it's one of their important ones that anchor the sort of northeast, southwest, and it represents the South Star during the evening hours in summer. Much higher up, the blue-white Altair, and you can usually see these two. The third one in a line here is a little fainter from the city, that might not be prominent, but also to look at here. Tucked down here is Sagittarius, and we call it the teapot, and you'll see why in a moment. And the Milky Way coming out of it, just sort of think of, oh yeah, there's a classic teapot. There's the handle, the lid of the teapot, and then the spout of the teapot here, and then steam coming out of the teapot, and that's our Milky Way. That's how we tend to see things here in Canada. The other thing that's quite striking in this is what we call the straight line, the two bottom stars of the teapot up through the bottom of Ophiuchus. This is Ophiuchus up here, big constellation, but it's got these regularly spaced stars with a nice doublet, and then on to Serpens, there's a nice pair here, and then finally on to it's Gamma Bootes, one of the stars just above Arcturus, and it's just this really neat, not quite straight line in the sky. So it's that should help you find Sagittarius, as you just essentially take the line and draw it right back down, and here it is. So the teapot in this shot here is from farther south. I've lifted it off the internet because I don't have a particularly good shot of the teapot. Even from places like writing on stone, the horizon is much closer to here. But again, here's the teapot all sketched out, and then the steam coming right out of the teapot. And the deep sky objects that Berta will be talking about are the Lagoon, which is right here, and the M22 star cloud. And those, if you're under a dark sky, even with a little bit of twilight, are visible to the unaided eye as a spot. You'll see the brighter blob here, and then, oh, got a detached spot, another detached spot. So here's the Greek classic. It's just like, what? He's a centaur, half human, half horse. But the stars of the teapot are just in here. And, you know, the rest you sort of can't really figure out much. It's all wild imagination. And that's why you just go with the teapot. So here we are from writing on stone. And interestingly enough, I was looking for some lore from the Cree nations that's available on the internet. And I couldn't find anything for Sagittarius. And then it suddenly hit me. Well, that's because when you're out under a dark sky, the stars of Sagittarius, here's the handle, the spout, the lid, and then the spout here. So here's the bottom of the spout. And I mean, you can see it's almost lost within the main Sagittarius central hub of our galaxy, the Milky Way. So it's not surprising, actually, that there is no real lore associated with it. The other two bright objects in here would be Mars and Jupiter. This is from a few years ago. No, pardon me, Saturn, and then Jupiter. And then over the last couple of years, Jupiter has sort of caught up to it and is now well on to the other side. And so here, again, we have the Lagoon and the star cloud. Okay, over to Berta.
Thank you, Alister. So, hi, I'm Berta. Alister and I do this together. We try to follow the Explore the Universe certificate, as he has indicated. That has several sections of objects that it guides you through several objects that you could look at. The first section is about constellations, and Alister just mentioned Sagittarius, which is maybe the constellation that you should try to look at this month, if you can. You are going to need a very clear horizon, like Alister mentioned. The second section in the Explore the Universe certificate is the section about the moon. So today we are going to review one Mare and one crater of the moon that you can look at when a little bit later in the cycle. The first is the Mare Tranquilitatis. So this is a view, what you see here in the image is a view of the full moon. And so it's a good time to see it, but any time that the moon is past first quarter, let's say, you will be able to see this Mare. So Mare Tranquilitatis is a basin which is around 880 kilometers across. So it's more or less the size of the Black Sea. And it's the place where the Apollo 11 landed. The first manned landing on the moon took place here in Mare Tranquilitatis. And then astronauts Neil Armstrong and Buzz Aldrin landed the Eagle module in this Mare and took here the first steps on the moon. So if you are curious about a little bit of lunar history, that's maybe interesting for you to try to find this Mare. You could certainly see it with binoculars. When you look at the moon past first quarter, it will be there. I want to talk about one crater that we want to highlight this month, and that crater is Theophilus. This crater is a prominent crater. It's easy to see, with a peak that is around almost 1 kilometer tall, a little bit more, 1.5 kilometers almost tall. And there are two craters nearby, Cyrillus and Catarina, that are also very prominent craters to be able to see. You can see by how deep the shadows in these craters are that actually the walls of the craters are pretty tall. As we always say, the best time to look at a crater is when the terminator, which is the line between day and night in the moon, it's when the terminator is near the crater, because that's when the shadows are the most striking and it's easier to see. Because if you look at a crater when it's fully illuminated, when it's fully in the day side, they kind of look a little bit more flattish and they don't have that much contrast. But when they're very close to the terminator, you can see very clear the lights and the shadows, and there's a lot of contrast, and that makes seeing those craters the best. So in order to see these three craters, Theophilus, Cyrillus, and Catarina, the best time is when the moon is around between 5 and 6 days old. And we measure how old the moon is by measuring how many days it is from new moon. So new moon this month, I think I checked. So it's the 28th of June, I think it was, new moon. And so then it will be June 4th, in the evening of June 4th, it will be around 5 to 6 days old. And thus the moon will look pretty much like we have here in the picture. The terminator will be very close to these craters, and that's the best time to see it. So if you can go out in the evening of June 4th and look at
July.
Sorry. Yes, thank you, Alister. I had a typo there. I meant July. Yes. So if you go out, and in the next slide is the same because it's copy paste. So I put June, but it should be July. Thank you, Alister. Yes. So if you can go out in July 4th in the evening and have a look, the moon will look similar to this, and you will be able to see these craters with binoculars. Thank you. And yeah, this is a picture of this crater from one of the moon orbiters. And so again, you can see how tall the central peak is and how tall the walls are. Is around 1,400 meters tall. And again, it's July 4th. Thank you, Alister. Yeah. And so now moving to the next section of the Explore the Universe certificate. The next section is actually about the planets, but the planets are best seen in the morning now and not even that much. So we will come back to talking about planets in the fall, because then Jupiter and Saturn will be up in the sky in the fall, in the evening. But now we are going to move directly to the next section in the Explore the Universe certificate, which is the deep sky objects. So I'm going to highlight two different ones. Again, we are coming back to the teapot, to the Sagittarius constellation, the teapot. The green line in this image is the horizon, is the line of the horizon. If you didn't have any mountains or anything, so any mountains or trees or anything, it's just gonna appear, it's gonna make the horizon line higher. So as you can see, Sagittarius is actually very close to the horizon here, as seen from Edmonton. So that's why Alister was saying you need to go to a place where you have a very clear horizon in front of you without trees or houses or anything in order to be able to see the full teapot. So the first deep sky object that I want to talk about is the Lagoon Nebula. It's also called M8. It's shown in here. And it looks like a fuzzy patch, like a whitish fuzzy patch in the sky. So it's kind of like an undefined cloud. And it's an emission nebula. It's very bright. And this huge cloud of gas is bisected at one end by a dark lane. So if you see it with binoculars, you can actually see that lane. It's around 4,100 light years away. And it's a nebula where new stars are being formed right now. It's just a cloud of gas and stars are being created in there. Emission nebula are clouds of ionized gas that emit light, and this light is due to basically shining through ionization, and this ionization is due to the photons for a nearby star. So basically there is a star close to the gas cloud that basically hits the cloud and makes it shine, and that's why we can see it. If you can go to the next slide, please, Alister. Thank you. And I did change a little bit I told Alister that I was going to mention a different object, but then I changed my mind because this is a much brighter object and it's probably easier to see with binoculars. So instead of talking about M24, I'm going to talk about M22, which is a globular cluster in Sagittarius. So the Lagoon Nebula was to the right of the constellation. This globular cluster is to the left. It's called M22. It's a cluster that is almost a magnitude brighter than the very well-known M13, which is another globular cluster in the constellation Hercules. So this one is really bright. And so when you look at it through binoculars, you just kind of see again, kind of like a fuzzy patch northeast from the top of the teapot. It's around 10,600 light years away from us. And it was one of the first globular clusters to be discovered in 1665, and it was discovered by Abraham Haile. Thank you, Alister. Again, in the question period, if you have any question about this or how to find these objects, please ask us. So the next section of the Explore the Universe talks about double stars. Okay, so this month, I'm highlighting for the summer two of the most known double stars. The first one is what we call the double-double, or is Epsilon in Lyra, in the constellation Lyra. It's a wide, easy binocular pair. And if you have a telescope and you look at it, you could actually see that every one of the doubles split again in doubles. So it's actually 4 stars. With binoculars, you most likely only see 2. But if you actually have telescope, you will be able to split those 2 into another pair of 2. So you will see 4 stars in there. That's why it's called the double-double. It's around 162 light years away. It has 2 white components, which can be separated easily by binoculars, and they do orbit each other over hundreds of thousands of years. So this is binary stars that are actually orbiting each other. They are gravitationally linked to each other. And again, when viewed with a telescope, you can split them again in another 2. Okay. And the next one is, of course, everyone's favorite double star. It's called Albireo, and I did put a big image here of the summer triangle. If Alister would like to, so when you go out in the sky in the summer until pretty much, let's say, end of September, this summer triangle, the Neb, Altair, and Vega, these 3 stars, as the first ones that you see as the sun is setting, looking south. So if you look south and as the sun is setting, the first 3 stars that you're going to see are these brighter ones, Vega, Deneb, and Altair. They are called the summer triangle. And this, the best way of getting to know your summer sky is by finding the summer triangle, because then you can find the whole Cygnus constellation and the whole Lyra constellation, and then Altair, which is from the constellation Aquila. And the Milky Way just goes across from the Neb to Altair. So if you are in a dark sky, you will actually see the Milky Way. And these are really, really beautiful constellations. And so Albireo is actually the head of the Cygnus. The Cygnus constellation is a swan. It's a swan that is flying in the sky over the Milky Way. And so Albireo is actually the head of the swan, and is double star again, and it's one of the most beautiful ones. You need steady binoculars, so you can mount it in a tripod, and they have to be some powerful binoculars, or even if you have a little telescope, that would be okay too. And then you can split these 2 stars. And the interesting thing is that their colors are really different. One is more of a yellow star, and the other one is more of a blue star. And when you see them together, the colors become really apparent to you. So that's why Albireo is always a star that everyone likes to watch, because it makes seeing the colors of the stars so clearly. Okay. And I think this was my last slide. Thank you, Alister.
Okay, so in this segment, just explaining a little bit about some of the other things that happen in the sky. And we here in Edmonton are perfectly placed to see what are called noctilucent clouds. And that's Latin, literally means night shining, lucent. It's the shining part. And nocturnal creatures, or of course you would know those are nighttime creatures, and hence noctilucent clouds. And so these are, this one on top would be considered a nice display. The one on bottom here would be a sort of a faint display. And at first you might think, oh, that's just the evening twilight shining on some high cirrus clouds. But these dark ones are the cirrus clouds. The sun has set even for those, but these clouds are so high that the sun is still shining on them. And I've got a neat little diagram. Okay. There we go. Too far. Oh, good. So This is essentially the geometry. We are here, O for the observer, and down to the far right would be the sun, well off the page. This is to scale, so this gently curving arc is the curvature of the Earth's surface. And the black line here would be the horizon. And these clouds are actually 80 kilometers up. So on the scale of this rather, well, seemingly large planet, 6,700 kilometers in radius, this little bit here is 80 kilometers high. And so if the sun, as an example here, is 7 degrees below the horizon, it essentially, the Earth casts a shadow out into space. And also the lower atmosphere of the Earth also casts a shadow because it's thick with all sorts of dust and particles. And so that shadow rises up into the sky. And so the part where we actually can see noctilucent clouds are where the sun can still illuminate them up in this band here. And then as the sun gets lower and lower, then this orange line sort of angles up to the point where you're only seeing noctilucent clouds very close to the horizon. But when noctilucent clouds are really bright, it's an incredibly awesome display. These are all displays from mornings. Noctilucent clouds are not best in the morning. It just so happens that some of my better ones have been that. But this one up here was basically an all-night display, and you just see all sorts of waves, and that's one of the things that really distinguishes them from cirrus clouds, is that I mean, cirrus does have some waves, but not like waves on the ocean as you see here. And the waves intersect, and they as you can see, they sort of crash into each other, and they sometimes form these really spectacular netting. And in binoculars, to me, they're just stunning. It's like looking at a Hubble Space Telescope image of the Orion Nebula. The amount of detail is just striking. They do move, but slowly enough that if you just stand there and watch with binoculars, you will not see the motion. But if you record them in a time lapse with the camera, they do slowly shift. And to help with when to look for noctilucent clouds, I developed a little web application at nlcplanner.com, and you just click on, say, this evening, and it'll run out the important times for the coming night, all in universal time, which for us here in Edmonton is 6 hours past where we are. So midnight is 06 universal time on the following day. And so 3 a.m. universal. And if you think of, where is London right now? Oh yeah, it's late for them. It's past midnight for them. Oh yeah, it's past midnight for them, then it's sort of evening for us. So this is 3 is 9 p.m. for us, 4 is 10 p.m., 5 is 11 p.m., 6 is midnight. Now here is the true middle of the night, because Edmonton is not in the center of our time zone. Plus, we're on daylight time, where we turn the clock forward an extra hour. So it turns out that the true middle of the night is actually 1:38 a.m. That's when the sun is lowest. It's 13 degrees below. But the key numbers in here are when the best contrast for looking at noctilucent clouds is when the sun is about 9 degrees below the horizon. And this is the NLC will climb as high up as 63 degrees. And then going from 9 to 10, and that's fairly fast here. It's not quite 20 minutes. Sort of in 15 minutes, the top of the NLC appears to drop from 63 degrees down to just below 30 degrees. And that's just because the sun is lower and lower, and the Earth's shadow is higher and higher. And so the Earth's shadow gets cast higher into the sky. And so the only lit part is what is available for us here. And so we can actually see, we're at the time of year now where we're very close to the average peak of noctilucent cloud activity. And we can see noctilucent clouds all night. In about a month's time, there'll be a little window where we have an evening window and then a morning window. But right now, they're visible all night, and if you've got a really nice display, you'll still see them 7 degrees up off the horizon. And just about in all noctilucent cloud photos, you'll see the bright star Capella. And so that's its altitude is given here on this chart just as a nice, easy way to refer, oh, you know, the clouds reach as high as Capella, so that must mean, and if it's at this time, boom, okay, it's pretty close to 30 degrees. So that's an easy way of looking for noctilucent clouds. I just want to leave you with a couple of images here. And Capella is in here somewhere, but it just goes to show you where this is so bright, it makes it hard to find one of the brightest stars in the sky. And you'll always see it only really in the illuminated arch. Wherever the sky is truly dark, it is the Earth's shadow that's getting in the way. And so you want to be looking to wherever the sun ought to be. In this case, well, the top of the arch is here, so the sun will be down here somewhere. And it can go pretty much all the way from the western horizon to the eastern horizon if it's a huge display. But sometimes it's only just these little patches. So what I want to truly end with is the planet lineup for tomorrow morning. You may have seen on news feeds all the planets line up in the morning sky, and yes, they do. But from our latitude, the line is fairly low angled to the horizon. Mercury is just here, so this is this is Stellarium, free software, and so with Edmonton's latitude and time of day, the sun is going to be rising in about an hour, but already the sky is very bright here. Mercury will be tough. We'll probably need binoculars to see Mercury, but the moon is nicely placed in this whole string. So this would be essentially the ecliptic. It's the disk on which our solar system seems to lie in a generally a flat disk, and we're seeing this disk edge on because we in the Earth are inside it. One of the things that's a bit special about this, either tomorrow morning, as I said, it's like it's a little iffy. Friday morning as well is going to be a bit tighter. But what people are also a bit hyped about is that the planets are in the order of the solar system. So Sun, Mercury, Venus, well, Earth, the moon is a substitute for Earth, Mars, Jupiter, Saturn. Uranus is actually in there, but it's not one of the naked eye planets, the classic planets, that is. So that's what's sort of, in a way, truly special about this. And as we go into the 25th, it's still there, but the reason you see the 24th as being the day is that it's, or the morning, is that the spacing is just really superb right here. But the 25th, we should still get Venus and the crescent moon should be very nice. So with that, I will stop the share, and we can click on see our gallery and take any questions.
You are welcome to ask questions or to put them in the chat if you feel like having. Last meeting last month, we talked about a little program called Sky Puppies that is designed for children, and Greg just told us that he requested it and got it from the Astronomical League, and apparently he likes it. It's a nice little program. I think it's designed for a school by Boy Scouts or schools or families, and it's a way of getting kids to introduce to the sky just with their eyes. So it talks about constellations and some mythology and so on. And you can request it for free from the Astronomical League, and they will email it. They will mail you a printed copy of the program. Or at least that's how it was. Was it like that, Greg, for you? Yeah, okay.
Yeah, I requested, I asked them if it was free in Canada. I mentioned I'd seen it on this talk, and they said it's free in Canada, and the only cost was they wanted to know who I was going to use it with, so they knew it was going out to an appropriate audience. And it took 3 weeks to get here, but the book looks fantastic, so I just received it this week. Yeah, so I really appreciate the referral. Thank you.
You're welcome. Yeah.
I've gotten a few of you who, you were let into the session a little late because I was looking at the weather, and I was noticing that basically Saturday morning is really our best chance. It looks like it'll be a very reliable chance, whereas Friday, well, it looks like it'll be fairly iffy, and tomorrow morning not all that much better, unfortunately. So it'll be pretty dicey tomorrow morning, pretty dicey Friday, probably still cloud remnants from the rain systems that are going through. Saturday should be nice, so I think I'll give it a whirl for them. You can sort of see it from anywhere as long as you've got the horizon. I'm going to be going to Valley View Crescent, just east of 142nd Street on the west side of the city. It's got a very nice low horizon.
What time will you be there? At 3:30, 4?
Yeah, I'll be there probably 3:45. It sounds awful. Although
yes.
every now and then I think, since it's going to be clear, there might be noctilucent clouds. Maybe I'll just stay up all night or grab a few naps in between looking at noctilucent clouds and just show up there. It's a nice place. One of my noctilucent cloud panoramas that I was showing earlier was from Valley View, and you have the city down below. So it's a nice spot for that.
Alister, just a simple rookie question. Which direction do I look to see the clouds? Is it always to the east?
It's always to where the twilight arch is. So at this time of year, it's basically, the short answer is north.
North.
In the evening, it'll be west to north, and then in the morning more sort of northwest to northeast. Because as it turns out, the clouds actually, the noctilucent clouds tend to move from east to west. So if there's a nice display, they do tend to scooch over to the west as well. But it's anywhere in that general north direction. Wherever you see the nice indigo, deep blue going into slight orange of the sky, that's where you look.
Thank you. Yeah, Valley View Lookout is one of my go-to places. So
yeah, sometimes they're just little patches, faint here and there. Other times they're in one area of sky. I've seen them come in from the east, and go to the north, and then they just, like real clouds as well, just dissolve, and oh, there's nothing in the morning. And there's really no predictability. I've seen cases where you go, oh, there's a fantastic evening display, nothing in the morning. Or, well, there's nothing in the evening, so I'm not going to bother. And then there's this fantastic display in the morning. And then every now and then it's great all night, and other times all night, but just these little wispy streaks. So it's all really a matter of luck. But with that NLC planner, looking at the timing for when the sun is -9, that is the sort of the sweet spot of, if you're looking for a nice display, guaranteed it's going to be visible when the sun is 9 degrees below the horizon.
What was the name of that website again?
NLC Planner.
I haven't had any luck looking for any clouds. I've been trying, but on a different subject, when you go out and look for things, I have trouble deciphering in my mind or in my, how much I use the 5 degrees binocular width or something to look. Do you use that all the time when you look for objects? Degrees?
Generally, what I look for, like my binoculars are 7 degrees. So I just keep that in mind. But all binoculars, typically they'll have a little, something like 7x48 or something like that. And then typically they'll have the field of view there. So 5 to 7 degrees is a typical 7 times binocular angle of field of view. So, it's tough if you're going to extrapolate 4 or 5, then it's really good to know more precisely what the field of view of your binoculars is. But I use 7 for mine, and so yeah, it's sort of edge to edge, or center to edge is 3.5, and then sort of work my way over.
And you use it all the time?
Yeah.
You can.
Go ahead, Berta.
Oh, I'm sorry, Alister. Yes, I wanted to say that for me, what I use that, but I actually don't do that. I use more, I do like star hopping. So I actually use the stars as a map. So you have to know your sky. So you basically, when you are looking through your binoculars, I have this little star atlas that I really like. Is the Pocket Sky Atlas, and it's basically what you see is from Sky and Telescope, but you can get it in Amazon, or at least I got it from Amazon. And the view that you have in there is like a atlas of the sky. It's the stars that more or less I can see from the city with binoculars. So I always have it in front of me, and I kind of look at my stars. So I start, of course, you always start on a bright one, and depending on where you want to go, for example, you want to look at, we talked today about M8, which is this emission nebula, the Lagoon Nebula, right? So you go, look, lucky me, I just got the right page. So I go to Sagittarius, and I probably will start in here. So I will look at it by eye and make sure that my binoculars, then the best thing is you look at it by eye and you kind of move them to your eyes, and then you will see this bright star. And it requires a little bit of training to translate what a bright star is by eye to a bright star with binoculars, but I guess you get the whole of it. You will get lost a couple of times, and then when you get lost a couple of times, then the third time you find it, and then you kind of start hop. So you go to there, and also this atlas has a circle in here that tells me the bigger one is 4 degrees, the bigger circle. So it tells me that more or less a circle kind of like that will be 4 degrees. So that's more or less what I'm going to see in my binoculars. And then I match in my mind what I see in the atlas to what I see in the binoculars. And then I kind of move slowly try not to get lost. I get lost sometimes, and then I start from the beginning again, and then you reach to the object. That is called star hopping, and that's what you also do when you have a telescope. And it's not go to, because the telescopes have the finder scope, which is basically like a little binocular. So that's how you find your way in the sky. Yeah, by having an atlas and then kind of slowly star hop from one place to the other and making sure that you're always keeping where you are in here until you reach where you want to go. Is that make sense? Maybe Alister, you have a way of explaining it
No,
that's
I
a
like
little bit
that.
better. Yeah, and so I like there are a lot of different atlas out there. This is not the only one, but I personally like this one, and I like that it has these circles, and this is a good one for binoculars. Of course, if you wanna have a deeper view into the sky, you need a more detailed one, but this is a good one for binoculars.
Yeah, and the key phrase there is the hop in star hopping, and it's just keying in on a pattern where you might go, okay, I'm looking for this thing, and so in binoculars I'll find this pair, and then I go, well, based on the chart, that looks like it's about 1.5 times what these are, and so it's like, okay, so then I whoops, I'm trying to do this on the screen and I'm getting myself mixed up. Where you then start at one, go to the other, and then go, okay, that's 1 time, that's 1.5. It should be pretty close to there, maybe 2. And so that is the key thing in star hopping. I use equilateral triangles if I can. Hockey stick shapes are very useful. They show up a lot. And so it'll be, I see, okay, there's a pair there, and then there's another one here, so that's my hockey stick. So it looks like it's, right up the middle of the crook of the handle of, and it's about the length of the handle of the stick. And so I use that a lot in framing which way to go, because especially if you have in a telescope, if you've got an eyepiece that flips things, it can get very confusing. So having something like the hockey stick, it'll go, oh, I need to go from the heel to the tip of the blade, and then I need to go sort of up relative to what a hockey stick is, or down, and then that way I'm anchored to sort of the pattern, no matter whether it's flipped or not.
Yeah. Good, thank you. I find it very confusing. You try your binoculars and you want to go 1, 2 or something like that, and you all of a sudden you lose your stars and you're back to begin, like your Berta says. I guess it's just trial and error.
Yeah,
but it's just go ahead.
Going sort of slowly enough, and sometimes the hop is too big, and if you're set with say dead reckoning, especially if you're out under a dark sky, good luck, because you suddenly go, oh, there's 40 stars in my binoculars and I have no idea which one's which. And then and so that way you then have to go back and be a bit more meticulous of going, okay, I'm going from that hockey stick to that equilateral triangle over to just that pair there, and you just, and if you get lost, you go back and you retrace it at the start of the hockey stick again. And eventually, and like that's going to be how to find the planet Uranus this summer will be that type of thing, because it's halfway between Aries, which is wonderfully a hockey stick pattern, and the tail of Cetus, which is a fairly faint kind of hexagon of stars, and it'll be in the middle there with 2 or 3 other stars of similar brightness, and so it'll be very much doing that mental thing of like blow up the chart a bit, so you're not looking at so that you're not looking at something that's too small, and you blow up the chart and you can plan out your sort of shapes. Parallelograms happen a lot, where you have the, you know, there. So it's that sort of slanted, you know, squashed box, and those are often show up there as well. And so it's the, for me, that it's that jump from pattern to pattern to pattern, and then you'll get there. And especially for something like Uranus, which just has a tiny little motion, unlike Jupiter, which does a much nicer sort of loop in the sky. Uranus is pretty tight, so it's always going to be in the same field for or area for all summer. And so once you've figured out your pattern to pattern to pattern to get to it, then it's this like the next night, it's like boom, 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 and you've got it in under 3 minutes. But it's that first night, it's like, oh, this is taking a while.
Well, thank you. That's a few nuggets to work with.
And as Berta said, and this is good for everybody as well. It's when you get used to it's the muscle memory, muscle motion thing, where you're looking at a star and you start with something nice and bright like Spica, Arcturus, Altair, and you just go, you know, where it is in the sky, to bringing the binoculars up. And at first you're guaranteed you're going to be shooting too low, and you think, oh, I just can't see it. It's like, nope, go a bit higher. And it's, for beginners, it's always too low. But then once you get used to it, you just go, boom. And so even if you're going into a part of the sky that's hasn't got any bright stars at all, once you've got that muscle memory in there, you just, and you can get really close to what you're going for. But it's practice, plain and simple. Okay, then, thank you very much for your attention. We will see you in September. There'll be obviously lots of notice on the website, whether or not we're actually meeting in person or whatnot. But do remember, next week, Jeff is doing What's Up in the Sky this month, Jeff?